The Nomadic Cooling X3 series is the smallest, most powerful rooftop air conditioner on the market, period. It is 7 inches tall. It allows you to park this vehicle in a 10-foot garage, in a Sprinter van with a high roof, with big tires. It is the only air conditioner on the market, period, that has a flush interior trim piece made out of aluminum. I'm so happy to show you our brand new Nomadic Cooling X3 and 48 volt. Guys, let's go. Now you out there might be thinking to yourself, why should I get a 48 volt air conditioner? Let's talk about it just a little bit. You just have seen the big on launching of the Tesla Cybertruck. It's the first truck out in the industry, the first automotive vehicle mass produced with 48 volts for all of the appliances inside the vehicle. And what we've learned by watching all of these videos is that we went from 12, we skipped over 24, went right to 48 volt. In the Cybertruck, it reduced the weight of the vehicle dramatically. It increases charging effectiveness and reduces heat within the system. What I really want to do is I want to show you the startup of the air conditioner. If you've never had a DC powered air conditioner, this is the main difference about how it starts up. If you've traditionally used a 110 air conditioner, you've probably heard about the startup surge or the amp draw right at the beginning. As we start this air conditioner, we're going to start it in high cool mode, and we're going to take a look at the amp draw, and what we're going to see is how the amps are going to slowly go up, and then as the compressor turns off, they slowly go down. What they don't do is they don't jump up and then drop down. So let's just take a quick look and see what it looks like here. So we're at 0. I'm going to go ahead and push the power button right here. It's in high cool mode. The amps we're at 5 amps. Eight amps, 9, 10, 12, 13. This is high cool mode. I'm going to keep my fingers on the thermistor so that it keeps thinking that it's hotter in here than it is. Kenny, we're at 70 degrees inside the warehouse today, and we just turned it on, and let's see what our temperature coming out is. We're at 52 degrees coming out right now. We're at 12, 13 amps of consumption at 50 volts. And let's check the temperature again. There we go. We're down to 45 degrees coming out of the AC. 12 amps. And we'll just keep checking here. Okay, we're at 42 coming out of the AC. Now we're at 39 coming out of the AC. Okay. We're at 10 amps right now, so the compressor has slowed down a little bit. It's not running as fast. My hand's literally freezing under here, but I think this thing's just garbage. It's not working that. Currently we're at 41 degrees coming out of the AC and still dropping, only using 8 amps. So let me go ahead and I'm going to show you one more time when we turn off the air conditioner. I'm going to hit the power button. Number slowly drops down to 0. The condenser fan on top will keep working for a little while till they've removed all of the heat out of the coolant system, and now you'll see it slowly shutting off. At 50 volts and 10 amps, we're basically at about 500 watts of consumption. Now, I do want to point out that this 500 watts of consumption, we're inside, and it's only about 70 degrees right now. This number will go up when this unit is outside in 120 degree temperature. Remember that the amp draw was always higher the hotter the temperature is outside. Unfortunately, it's just wintertime here in Phoenix, and so this is the testing that we can do today to show you. But we will do more testing in the summer with the X3 X2, 12, 24, and 48 volt. It took us a lot of work to come to market with this 48 volt system, and I'm going to tell you why. Every single competitor on the market uses a DC to DC converter inside their air conditioner to run it. Now, what do I mean by that? Their sticker on the back may say that it's 48 volts, but it's probably a 24 volt air conditioner with a DC to DC converter in front of that. So it comes in at 48 volts, it goes out of the DC converter at 24 to run the compressor and the fans all at 24 volts. This would have been the easiest thing for Nomadic Cooling to do. But as you've noticed with our air conditioner, we don't have any room inside the AC to add a DC to DC. The other problem with doing that, when you add things on top of the roof or inside the air conditioner that add complexity, it's one more thing that can fail. And Nomadic Cooling isn't interested in selling you an air conditioner today and then making money solving the problem tomorrow when it breaks down. What we want to do is we want to design the air conditioner in a way that it reduces all of the pain points and the failure points within the system. Now, once again, what do I mean by that? If you take off the shroud of a Nomadic Cooling X3 series air conditioner, the only thing that you'll find in there that can really break is one relay. There is one relay on top of the AC. Everything else is done inside of the control panel. On the 48 volt version, we took this to a whole new level. This is a control panel for the X3 48 volt air conditioner. This is brand new to Nomadic Cooling. Everything about this has been redesigned for the 48 volt air conditioner. You notice on the back of this board, what we've added in here is we've added the DC to DC converter inside the control panel. It is not inside the air conditioner. It is not a separate piece that can break. This control panel actually converts from 48 volts down into 12 volts to run the fan. Now let's talk about this for a reason. Why would we spend all the money and all the time and all the engineering effort to make that happen? You have to remember that this control panel is inside the vehicle. That means that if something happens to the air conditioner and it's not working, we know that we only have one relay on top of the vehicle, but it means that 98% of the time, if it's not working, it has something to do with some of the electronics inside the control panel. This control panel can be replaced in about 10 minutes inside your vehicle without going on your roof. You can tell the manufacturing, everything in here is waterproof. We have an inline fuse in here. The quality of it, it's simple. Tells the air conditioner when to turn itself on, when to turn itself off, how to match the speed of the compressor with eco mode and high cool mode. If we were just trying to come to market as soon as possible, as I mentioned earlier, we would have just added a big DC to DC converter inside the air conditioner, as some of our competitors have done. I believe this is a better user experience and easier for us to replace parts if something happens in the future. I always say with electrical components, as everybody has tons of electrical components, you build it not to break. But you also build it so that if it does break, it's easy to fix the problem. All of the Nomadic Cooling air conditioners, the X2s and the X3s, are the only air conditioners on the market, period, for the RV space that have a high and low port that can be filled from a traditional air conditioner fillings machine that you can find at any mechanic shop for automotives anywhere around the country or down in South America. That means that if something happens, even if something happens to the compressor, it can be taken off, a new one can be put on, and it can be refilled. Nomadic Cooling air conditioners are not designed to be thrown away and make you buy another one. So what we're seeing is that the air conditioner at 48 volts uses less consumption than a 12 or 24 volt overall. The wires that go from the power source to the AC are smaller, less heat within the system. Have to remember that the heat in the system is wasted electricity. The more heat that your inverter puts off, your air conditioner puts off, the wires going in between your different appliances within your vehicle, that heat is wasted electricity. It's resistance within the wire and the appliances themselves. As you're pushing 12 volts up to a 12 volt air conditioner at 100 amps, you need a larger gauge wire. We suggest a 2AWG wire for any sort of, Class B van. Now that wire has to be thicker, which adds more cost, more weight, but also more heat within the system. And everything that we want to do within an electrical system in an off-grid application, even in a tiny home application, is reducing the cost of wire, reducing the weight of the wire, and most importantly, reducing the heat within the system. The less heat that we can cause within the electrical system, the more efficient your electrical systems becomes. When you go and you look to buy batteries for your 12, 24, or 48 volt electrical system, you want to look at your rate of charging as it becomes very important. How long do you need to be plugged in at your campsite? You'll probably find that your batteries charge faster between, say, 0% and 80%, but that last 80 to 20% takes a lot longer to charge the electrical system. At 48 volts, when you compare it to a 12 volt system, your time to charge your actual battery pack is reduced. If you're building a vehicle specifically for yourself, there are pros and cons if you're deciding between 12 and 24 and 48 volt. I will point out to you that if you get a 48 volt electrical system, this is missed by some people, you're still going to need a DC to DC converter at some point to power your refrigerator, your lights, your awning, your other ancillary devices throughout the system are all still going to be running on 12 volt native. So at some point your battery, your air conditioner can be paired up at 48 volts. Even your secondary alternator coming in could be 48 volts. Everything that produces a lot of power, uses a lot of power, all 48 volt. But your other devices, your smaller ones, will still need something that goes from 48 to 12. If you want the best air conditioner on the market, period, no questions asked, the Nomadic Cooling Air Conditioner is for you.